Okay, so welcome back. So now in this video, we're going to talk about the error bounds for using the midpoint rule and the trapezoidal rule. So in the previous videos I did, we calculated what the absolute value and relative, the absolute error and what the relative error are. But that's using the fact that we know what the actual true value of the area under the curves or the integral was. In most cases, we don't know what the true value is. That's the whole purpose of what we're doing, right? We're approximating things. And so if we had the true value, we wouldn't need to approximate it, right? So this brings up the idea of, well, is there an upper bound to how far off we could be in error? And the answer is yes. So for the midpoint rule and the trapezoidal rule, there are formulas that will give us the maximum error bound for an approximation using either one of those rules. So here's the theorem, okay? So now again, I'm producing this without proof, okay? But again, just know this theorem, okay? So it says, let f be continuous over the closed interval from a to b, having a second derivative that also exists, right, over this interval. It says if m is the maximum value of the second derivative in absolute value, the absolute value of the second derivative, if that exists, right? So if there is a maximum value over that interval, right? Maximum value of the absolute value of the second derivative of the function, then the upper bounds for the error in using m sub n and t sub n, using the midpoint rule and the trapezoidal rule to estimate this integral, the integral of f of x dx from a to b, okay, is given by these two formulas. So in using the midpoint rule, our error, the maximum error, is given by this, this expression here. M, capital M, so that's the maximum value that we found. The m times the quantity b minus a cubed divided by the quantity 24 times n squared, okay? Now, the error in using the trapezoidal method is double. Right? It's the same thing, but it's usually double. So you notice it goes from 24 to 12. Okay? So the maximum error in this case is effectively double. Okay? Because now instead of dividing by 24, you're only dividing by half as much, which means your error bound is going to be double. So one way to look at it is your error bound for the trapezoidal rule is going to be double than what you get for the midpoint rule. But anyway, the error bound using the trapezoidal method is going to be capital M times b minus a quantity cubed divided by the quantity 12 times n squared. Okay, so these are the two formulas you're going to use to figure out what the maximum error is. Now, the other thing too is we can use this to answer questions like, what is the, how many subintervals? Like for example, trying to figure out what the value of n needs to be, right? How many subintervals do I need to take, right? In order to guarantee that my error is no bigger than blank, whatever it turns out to be, okay? Or whatever you're given. So that's the other thing that we can use. We can use this to tell us how many subintervals do we need to take in order to guarantee that our approximation is going to be less than a given amount, okay? So that's what we're going to take care of next.